Hello, my name is Nicholas Luke, and I'm a senior at China University. I'm part of the senior design project of the aquaponics monitoring system, which we have dubbed Aquanota. Alright, I'm going to be going over my role in this project and how I impacted it. Alright, so first a little background information. As you can see here, we have the fish tank, which is going to be our water supply. We have a temperature sensor, an electroconductivity sensor, and a pH sensor. The sensor is connected up here via this circuit to a Raspberry Pi. The Raspberry Pi is programmed so that it'll be sending data periodically over to the cloud. My job was to make sure that this data was processed and could actually be stored inside a database and make sure that the database could be accessed to be used for other purposes. All right. Now on to my specific role in the story. As you can see here by my screen, we have set up what I call an applications programmable interface, or an API for short. What we have here is we have different resources that could be functions in the URL. For example, website / tank data / tank number, which would just be a 1 in this instance, / sensor data. We have multiple versions of these, one for error messages and one for the actual numbers for the values from the sensors. As you can see, there are multiple options here. These are the resources for get, post, and options. Options mostly handle the options for the API functions. All right. What we want to look at is the get and post functions. Get functions are those that retrieve data from the database that matches what we want, that matches what the input requests. For example, if we put get function right here and we typed in tank number 1 in the URL, it retrieved data for all of tank 1. Alternatively, we have the post functions, which is designed so that it's supposed to post data to the database, which we take from the Raspberry Pi and then post to the database. As you can see, a typical API function looks something like this. It makes a request to the method, integrates it, we get a response, and then keeps responding. Make sure that basically the API is just a sort of web that connects all resources together. All right. As you can see right here, this is the function that we use to code it. I'm going to open it right now. All right. This was coded in AWS Lambda. AWS, or Amazon Web Service for short, is the set of online resources that we use to code most of the project. All right. As you can see here, this is the code we used in order to post the data. And actually, this was to retrieve the data from the table, the database table. All right. This was coded entirely in JavaScript. Basically, it just lists all the parameters that we've set up for the table, limits it for scanning, makes it a return so that it will return the data back to those who requested it, and if there's an error, it will return null. Also, for a little side information, I was personally set up as the administrator of the whole project, assigning small user accounts for each group member and also assigning roles and policies. The policies are guaranteed to allow access to certain resources. So, for example, I allowed administrator access to all the other members, and more specifically, I wrote a policy that made it so that the Lambda functions could access the DynamoDB database, which we'll get to later. I can assign Lambda functions to have any of these roles that they could be used anywhere, make sure they have access to certain functions and resources. All right. So now if we go here in this tank data table, this will be the database that I was talking about, storing all the values that we have. As you can see, we have entry ID, subject event data, subject event ID, submitter date, and submitter ID. Submitter ID is supposed to be the tank number, in which case it's just 1 because we only have 1 fish tank. Submitter date would be the date and time that we submitted the data. So for example here, submitted on the 2019 April 24th at around 11:30 in the day. This will give us the temperature value of what we wanted, the subject event ID, and the subject event data is the value, which was about 23.7 degrees Celsius. The entry ID comes from the Lambda function, in which we had to just auto-generate a random string of letters and numbers. Basically, it's designed so that it'll generate so complicated and random string right there that it can't be replicated. Which, since entry ID is the primary sort key of the whole table, is a good thing, because it can't have two of the same for the sort key. Basically, my entire job was to make sure everything was lined up in the API gateway. So, once all these methods were defined and all these resources were defined, I would have it so that I could deploy the API as it was, like this. So, for example, I just set it to beta as the deploy stage. Once that was done, I could head over here. And using this URL, I could have it so that one of my other group mates could access it and code it into their user interface. So they could, meaning that they would take data from the database and using that, transport it to a user interface that they had, and it would show the data as colorful graphs and numbers. And depending on the data values, if the data was, the sensor values were outside of the optimal range, it would deliver a message indicating an error. So for example, if the pH was too high, it would say, alert the user that the pH was too high. Thank you again for listening to me. I hope you have luck in your senior design project.